Okay, so we're gonna run through this project. You can get started on it before I see you next time. Maybe you have some questions. All right, so I'll be emailing this out to you later and post it on the web too. For the project, you're gonna explore expected values a way of simulation. So you're gonna be using Excel to simulate data like we did last week in class. Um, this where you'll be given a card. I'll actually email you specifically. For instance, I might say to you, you're gonna use binomial 20 comma 0.5 or something. We can do that one probably, but whatever. I'll give you two of them. So one might be binomial, one might be Poisson, or one might be whatever it happens to be. You're going to simulate them, and then find the expected variance and the expected value and the variance in both of them, and how does it compare with theoretical. We do a lot of comparison with theoretical. Okay. For this part, you're going to simulate two different columns of data with normal distributions. And different means standard deviations, at least 2,000 each. You explore the expected value of x plus y, the variance of x plus y, expected value of x minus y, variance of x minus y. How will they match? Compute, and then you're going to compute ax plus by and see how that does. Notice that a is the second number in your phone number after the area code. So 503, don't want that. And then, like, say your number's 267 or something. So 503, 267, I'd want the 6 out of that deal. Okay, I want this to be somewhat random. And then B is the date of your birth, so you're born on the 10th, so B would be 10. And then how well do they match up with theoretical as well? Let's see here. Find a random number generator. This one is a little tricky. I'm trying to get more stuff to play with. I can generate Poissons. I can generate, normals, and a whole bunch of other ones. What I cannot do without looking around for it. So this is why I'm trying to help you, get you guys to help me out here. I'd like to be able to generate geometric distributions, negative binomials, multinomials, and hypergeometrics. Notice I don't want a CDF or a PDF. I want you to be able to simulate, or generate random numbers. Okay. So in the spreadsheet, which will also be posted, which I think is right here. Yes, there it is. There are a zillion columns. I want you to choose 3 of them. Your choice. I don't care. And I want you to figure out from whence they came. So did this column 3 here, did it come from a normal? Did it come from binomial, Poisson, whatever it happens to be? Okay. And we talked about that in class last week, how you go about trying to figure that out. Look at use the pivot table data, come up with, the frequency table. If, only like 5 different things can occur, obviously, then it's a discrete distribution. If there's quite a few different ones, but only whole numbers show up, it's also discrete, right? But it might be like a Poisson, or it might be a well, not Poisson. It could be a binomial. It could be something like that in nature. So it wouldn't have to be just a discrete distribution. Then you're going to present your findings being PowerPoint, PDF, whatever. I don't care. If you want to use a Google site, you can use that. I don't really care. Make sure if you can't embed the spreadsheet, just go ahead and email it to me. I guess I'd rather have 2 emails, or not 2 emails, but 2 attachments. One for the PDF, and then one for the Excel, so I can look them over. Anyway, that's your project, and again, this will be coming out to you shortly, and we'll see where we go from there.